Hi everyone, welcome to Homework Help for Lesson 38. Let's go ahead and get started. Number one, the ratio of walkers to joggers was 3 to 7. So for every 3 walkers, we have 7 joggers. What fraction at the track of the athletes at the track were walkers? So in order to determine this, we have to know how many total athletes there were there. Now we might not know the total number of actual athletes, but we do know the ratio of total athletes. 2 walkers and 2 joggers. Now, we find this by actually combining the two numbers that are part of our ratio, which in this instance are 3 and 7. So if you were to combine them, that's going to give you 10 total athletes as a ratio. And then how many of those were walkers? You just look at the ratio comparing the values. And the ratio for walkers is going to be your numerator. And that will give you the fraction of walkers at the track in comparison to the overall number of athletes that were at the track. Number 2, Denise read a 345-page book in 3 days. What was the average number of pages she read each day? So in this instance, we're already given the total amount, the sum of everything that she did over the period of time in which she did it. We don't have to add up, 100 pages on Thursday, 200 on Friday, 45 on Saturday. We're given the total. So all that's left to do is divide. We can use long division. Let's just do a quick check to see if our answer, our quotient will be a whole number or a decimal. And we're going to use this by using our divisibility rule for 3. So we look at 345 and we add up all the digits. 3 plus 4 is 7, 7 plus 5 is 12. Can 12 be divided by 3? Yes. So our answer will be, our quotient will be a whole number. Number 3, Connor ran a mile in 5 minutes 52 seconds. How many seconds did it take him to run a mile? So we're gonna have to convert. We already have 52 seconds, which is great, and we're gonna have to add the minutes. The only issue with the minutes is that it's not in seconds. So we have to convert 5 minutes to seconds, and we do that by identifying how many seconds are in a minute, which we know should be 60 seconds, is 60 seconds. And then from there, all you have to do is multiply 60 times 5 to get the number of seconds in 5 minutes. And then you add it to 52 to find the total number of seconds it took him to run a mile. For number 4, refer to the graphs in this lesson to answer problems 4 through 6. Number 4, how many fewer cans were collected by students in room 18 than by the students in room 16? So in this comparison, we just have to find the value for room 16 and the value for room 18. And then since it's fewer, we're going to end up subtracting. For room 16, it looks like we have about 9,000 cans. If you watch the practice set, you know that we're using K for 1,000 instead of writing the 3 zeros. And then how many cans were collected by room 16? It looks, well, room 16 is 9,000. Room 18 is 4,000. So all we're really doing is subtracting there to find how many fewer cans. For number 5, if Paul scores 185 in game 7, so let's say that he bowled another game because Paul has nothing better to do than to be at the bowling alley. So it looks like that's very similar to what happened in game 6. What will be his average score for all 7 games? So for his average score, what we want to look at is how much he bowled in each game. So we have, we have 160 from the first game, and then we have 170 from the second game. And after that, in the third game, he scored 175, or he bowled 175. And then the fourth game dropped a little bit to 170. Fifth game shot up to 180. And then sixth game hit 185, which is what he did again in the seventh game. So he should probably cut his losses there and go home. So to find his average, unlike the problem earlier, we actually have to find the sum of all of the numbers given, all the values given to us here. So you would add these up, And then you're going to divide that sum by how many games he bowled in, which was 7 games. For number 6, use the information in the graph in example 3, which is the one about Paul's bowling scores, to write a problem about comparing. So this is really going to be up to you, but you could, if we're comparing the values, you could say how much more did Paul score in game 6 compared to game 1? What was the total change in the score from the second game to the fourth game? So really, the comparison problem that you write can be about anything as long as you're using the bowling scores in these games as your content for the problem. And as long as you're comparing the scores in some way, shape, or form. And typically with comparing, you will be, subtracting to find the value. Number 7, diagram the statement and answer the questions that follow. So we're going to make a diagram. It says Mira read 3/8 of the 384-page book before she could put it down. I've been there. So we're going to make a box. And since we're doing eighths, we're going to split it up into 8 equal parts. As equal as we can get it, right? So right there we have fourths again. And then we split each of those in half to get eighths. There we go. Now we do have a total of 384, which means that each of these, to find the value in each box, we need to divide 384 by 8. Looks like she read 3 of these sections, and that means she did not read 5 of the sections. So then we have our dividing line here between what she did read and what she has not read. So again, to find the value of each box in the diagram, you have to take 384 and divide it by 8. How many pages did she read? That's going to give you, once you divide that, just count up these 3 boxes, add them up to get A. And then for B, how many more pages does she need to read to be halfway through the book? So this is a little bit different because halfway through the book is half of 384. So you're going to have to find half of 384, which you could calculate mentally or you could do long division. And once you have that quotient, you're going to subtract the answer from A, which is how many pages she has already read. Another way that you could solve that without the calculations would be to look at the diagram, right? And identify what the halfway point is. It looks like this is about half. So she's already read 3 sections. She only needs 1 more section to get to half. So that 1 section is going to be how many more pages she's going to need to get to that halfway point, which is represented here. For number 8, refer to the figure at the right to answer questions A and B. Dimensions are in inches, and all the angles are right angles, which means we can split them up into rectangles. Perfect. What is the area of the hexagon? To find that, we need to make our two rectangles, find the area of each, and then find the sum. And so for this instance, we have a 6 by 12 square here. So that's your area there. And then for this larger one, we have 18 by 20. That makes it pretty easy to solve. Once you have your products, you just add them, find the sum to find the area. And since dimensions are in inches, we're going to go with inches squared. Now to find the perimeter, we need to know all 6 of the sides. So as we mentioned multiple times, this side length is going to be the sum of the opposite sides, which is 12 and 18. So that's going to give you 30. And then this side length is going to be 6 plus x equals 20, which will make this 14. So now you have all 6 of the sides that you need to find the perimeter of this hexagon. So the only thing left for you to do is to add them up. Number 9, complete each equivalent fraction. So you just have to find the factor that you would multiply by to get the whole fraction or the given fraction. So, 9 times 4, something times 4. So you could reverse and divide 20 by 4. Here you would multiply by 6. And again, 24 divided by 4 is 6, so that's how we found the 6. So you do the same thing to the denominator. What property do we use to find equivalent fractions? We use the identity property of multiplication because, there you go, because we're multiplying the fraction by a fraction that's essentially equal to 1. So really what we're doing is we're just multiplying by 1. And as we've gone over, anytime you multiply by 1, you're not really changing the value of what you have. It's going to be the same thing. In fractions, it works a little bit differently because multiplying by 1 can also be multiplying by a fraction, where the numerator and the denominator are the same thing. Since functionally we're multiplying by 1, we're not changing the fraction, we're just changing what it looks like. For number 10, round 2,986 and 34,157 hundred thousandths. Round it to the nearest thousand place. So we want to look at the thousands place, which is our 2 here. Everything to the left will stay 0. Nothing to the left. So this is either going to go up or down. Given the 9 is the number directly next to it, it's going to go up. So 2 becomes a 3. Everything else becomes a 0. Number 10, rounded to 3 decimal places. So that would be the 1. Everything to the left stays the same. So 2,986.34. And then the 1 will either change or stay the same, depending on the number next to it, which in this case is 5. Number 11, the face of the spinner is divided into 8 congruent sectors. The spinner is spun once and only once. On which number is it most likely to stop? So which number is represented the most amount of times? Since they're all equivalent sectors, you just look at which number shows up the most number of times. And that's going to be the one that is most likely to stop because it has the greater odds. For letter B, on which number is it least likely to stop? Which number is represented the fewest times? That will be the number on which it is least likely to stop. So look at the one that has less sectors. For letter C, which is the better sample space and why? Remember that with sample spaces, we always want to list every single thing that could happen, even if it's a repeat or if it's the exact same as something else, right? So in this instance, the sample space should be all of the possibilities listed because it shows you every single outcome. This only shows you the different types of outcomes that can occur, but it doesn't really tell you anything about which one happens multiple times or could happen multiple times. 12, find the length of the segment in centimeters. So we're using the big numbers, 1 centimeter. And then since we're using a metric system, that's base 10. So just count the number of ticks to get to the 10th place here. For millimeters, every one is now actually 10. And then every tick mark represents 1. So millimeters is going to be a whole number with the similar ones place as the 10th place in number 12. Number 13. Find the perimeter of this rectangle in centimeters. So we already have 1.2 centimeters. We have to turn 10 millimeters into centimeters. We do that by dividing by 10. Every 10 millimeters is 1 centimeter, so that's 1. And then we're going to add a terminal 0 to keep those places the same, the number of digits, so that when we add them, we can line up everything. In rectangles, opposite sides are congruent. And now we have our 4 sides. We just add them up. And that will give us this perimeter in centimeters. 14, which point marked on this number line could represent 3.4? So we look at a number like 3.4. It's between 3 and 4. So that automatically disqualifies A and D. leaving us with B or C. Now 3.4 is pretty close to half, but it's not exactly half. So you want to go with the point that is closer to the halfway point of 3 and 4. In the figure below, diagonal AC, which is this line here, divides this quadrilateral ABCD into two triangles that are congruent, or two triangles that are exactly the same. Same size, same shape. Refer to the figure given here to answer 15 and 16. Which segment is perpendicular to AD? So which line is going to be perpendicular to AD? It's going to be the line that forms a right angle with it and has a common point, which is this line right here that I just highlighted. Which segment appears to be parallel to AD? So parallel works a little bit differently because now we have a line that we don't want to cross that is opposite of it, and that kind of flows in the same general direction, highlighted there. And again, they'll never cross, they don't have common points. 16. The perpendicular sides of ACD measure 6 centimeters each. So the perpendicular sides of triangle ACD. So this triangle, the sides are perpendicular, are both 6 units long, 6 centimeters. What is the area of ACD? Well, to find the area of ACD, we have to look at so what we're doing with this triangle is using the base and the height to find the area. Now, the tricky part here is you might think, well, what are the base and the height? Like this is clearly the base, I don't know what that is, and this is clearly the height, I'm not sure what that is. But since it's a right triangle, as we mentioned yesterday, the sides that are perpendicular are actually your base and your height. So this is the base, this is the height. So then just to find the area of it, you multiply your base by your height, and then you divide by 2, or you take half of it, whatever floats your boat. For CAB, it's the same thing because opposite sides in this quadrilateral are going to be congruent since they're parallel. So again, you have a 6 by 6 base times height that you're then taking half of. What is the area of the quadrilateral? Well, to find that, you just add the area of the two triangles. And it is going to be in centimeters squared for each of these. Solve. So now we get into some solving for variables. So a plus 4.3 is 6.7. I moved the a and the 4.3 around using the commutative property where I can change the order. Since we're adding, you want to do the opposite of addition, which is subtraction. Make sure you line up your decimals. For 18, m minus 3.6 equals 4.7. In this instance, we are subtracting. So we are going to do the opposite, which is add 3.6 to both sides. For number 19, 10w equals 4.5. The variable and the coefficient are being multiplied, which means the opposite is to divide. And we can actually use mental math here. Since we're dividing by 10, a power of 10, we just move the decimal to the left once for every 0 in that power of 10. For number 20, x divided by 2.5 equals 2.5. Since the divisor, or since the dividend is the variable, then we can just actually use the inverse operation, which is multiply 2.5 times 2.5. We can just do 25 times 25 and then move the decimal to the right or to the left once for each 0. Once for each digit after the decimal in both numbers. So it's going to be twice after you write down your number or your product of 25 and 25. 21, simplify. 5.37, 27 and 7 tenths, and then 4. So we want to make sure that they all have decimals, that they have the same number of digits after the decimal, and then we can line up our decimals and find the sum of these numbers. 22, we will use long division. So that's going to be 1.25 inside the division box. We place the decimal directly above itself, and then we just divide like we normally would. For 23, 5/9 times 6 over 1 times 2 and 1/10. Just a reminder that whenever we have these types of problems, you want to make sure that they're all in proper fractions or in fraction form. 2 times 10 is 20. 20 plus 1 is 21. And then from here, you can multiply and then simplify, or you can cancel and then multiply. I'll get us started with canceling. The 21 would turn into 7 because we can cancel out a 3 between the two, right? There we go. So now it's 5/3 times 6 over 1 times 7/10. Continue canceling or multiplying, and then you'll find your answer, or your product rather. 5/8, 3/4, 1/2. We're finding the sum. In order to do this, we need common denominators. Using a bit of mental math, I know that the common denominator is 8, so I have to change the 4 into 8, multiply numerator and denominator by 2. For the 1/2, multiply numerator and denominator by 4. That will give us our new fractions with the same denominator, and then we find the sum of all of them. So you have 5/8 plus, that's not -8, that's just me being sloppy. Denominator out of 8, and crazy 8s. That's what we're going to have here, crazy 8s. All right. 25, whenever we're dividing with the mixed number or with the fraction, we want to make sure that both numbers are, fractions. And then 3 and a third, we're going to turn into an improper fraction by multiplying the whole number and the denominator. 3 times 3 is 9. Then we add the numerator. 9 plus 1 is 10. So we have 10/3. And the only thing left to do from there is divide. Just kidding, we're not going to divide. We have to keep the first fraction the same, change division to multiplication, and then take the reciprocal of the third portion of this problem, which is the second fraction. From there, you multiply and simplify, or cancel and multiply if you like. 26, 3/10 minus 1/2 minus 1/5. Again, using mental math, I see that the least common denominator is 10. So 3/10 is already out of 10, so we leave it. And then we just focus on the ones that are inside the parentheses, which is 1/2. So we're going to turn that into a fraction out of 10. Same thing with the 5th. We're going to turn that into a fraction out of 10. You will multiply both by the factor that you will need. And then for 1/2, well, half of 10 is just 5. So that's how I know that. So then all you need to do is 5/10 minus 2/10, and then 3/10 minus that difference. And simplify if you can. Which of these is equivalent to 2 to the power of 2 times 2 to the power of 4? Well, this is a little tricky now, isn't it? But, as a reminder, if they have the same base, we can just add the exponents. Okay? So it would actually be 2 to the power of 6. And using the process of elimination, I know it's not going to be 2 to the power of 8, right? Because same base but different exponents that we ended up with. It's not going to be 4 to the, well, I guess it could be 4 to the power of 8. We'll come back to this one. It's not going to be 4 to the power of 6 because the exponents are then the same, right? And the bases are different. So that's going to disqualify it. I believe there are some instances where that could work, but no, I can't. No, I can't think. The exponents could be different, and I think that's like 1 to the power of 1 and then 1 to the power of 0 would both give you 1. But that might be the only case. Anyway, going back to this. So here's the thing with C. All right, even if I'll get to why this works in a second. But even if you didn't really know which one the answer would be, we just have to think about this logically, right? 4 is a larger base than 2. 8 is a larger exponent than 6. As such, the base and the exponent are both bigger, meaning the number is more likely going to be bigger than the one that we're looking at. So for that reason and that reason alone, well, not that reason alone, but for that reason, without having to multiply, just using what we know about numbers and exponents, we can see that 4 eighths is not going to be equivalent to 2 6. So now why does 4 to the power of 1 times 4 squared work? Well, that's going to be 4 to the power of 3, right? Now, if we were to expand out 2 to the power of 6, we have, I'm going to actually use the typing here because this could take a while. 2, 2, 2, 3, 4, 5, and 6. Here's the thing. We have 6 2's, right? We can actually regroup them into groups of 4, right? So there's one group of 4, and I'm going to explain why they're groups of 4 now, because when we have exponents, we know that we're just multiplying, right? So 2 times 2 is 4, so that's 1 4. 2 times 2 is 4, 2 4s. 2 times 2 is 4, 3 4s. So there's your 4 to the power of 3, equivalent to 2 to the power of 6. 28. How many milliliters of liquid are in this container? So milliliters, it's already given to us here, would be 100. It's definitely going to be more than 100. So we have to basically figure out what the value of each in between little space here is. It looks like there's 4 of them, and it's going to be 100 total. So we have 100 divided by 4, which means each of these is about 25. So that means that the liquid amount is 100 because it passes the 100 line and then gets to that next tick mark, which is the 25 line. So it's 100 plus 25 milliliters. No need to convert. The amount of liquid in this container is how much less than a liter? Well, a liter, milli, for those of us who, are familiar with Spanish, milli, mil, 1,000. When you're talking about milliliters, you mean that you need 1,000 of these to make a liter. So then to figure out how much less than a liter it is, you just take 1,000 and subtract your answer from A. 29. 5 books on the library shelf were in the order shown below. Which 2 books should be switched so that they are arranged in the correct order? We're looking at decimals now, and this is the Dewey Decimal System for arranging books in the library. First and foremost, if we're looking at decimals, they need to all have the same place value. So let's take care of that right away. Or they all need, yes, the same place value. The same number of digits after the decimal. So now that we've done that, they have to be in order, right? So we see that they all start with 916. Great. No changes there. We look at the next set of digits. 3, 3, 4, 3, 5. And there we see a discrepancy where these two should probably be switched for sure. And if they are done so, then we go back and double check to make sure everything's in order. 0, 5, 7, 2, 0. Now, if you're looking at it that way, then yeah, you might think, we need to move some things around. But look at the number before it. 30, 35, 37, 42, then 50. Switching those 2 books will give you the correct order. For number 30, you guys might not be able to access a graph, but if you just draw it to the best of your abilities, we'll go with that. So let's read this problem. On graph paper, we'll now draw a ray from the origin, which is 0, 0, to the point -10, -10, which is in the 3rd quadrant. So that's the first thing we're going to do. We're going to draw a decimal point at -10, 10. So we have -10 and -10. So we're going to put a coordinate point right there. And then drawing a ray means that it goes on forever in one direction with one endpoint. So we start at 0, 0, and then we go to -10, -10. Great. And then draw a ray from the origin through the point -10, 10. So -10, still on the x, -10, but in this instance, we're going to go in the opposite direction from the other one. So we find ourselves in the 2nd quadrant, and we still draw a ray that goes through that. Then we want to use a protractor to measure the angle formed by 2 rays, write the measure on the graph paper. So if you look at this, it's actually pretty interesting We're not going to need to use a protractor here. Uh, in certain instances where you have coordinate points that the only difference between them is the sign, you're going to end up with either 90-degree angles or 180-degree angles. For example, if this was 10, -10, that would give you a straight line, which is 180 degrees. Now, if this was not -10, -10, but instead 10, 10, you would also see that it would give you 90 degrees. So in this instance, we have a right angle, which means that the measure is 90 degrees. And we'll get into that later in the year about how certain angles are formed by coordinate points and how we can calculate the measure of the angle without using a protractor, just going based off of what we know about the coordinate points that are given to us. But those are special relationships that we'll explore later on. But essentially, you need your graph paper to look like this. Maybe a slightly better, uh, square that I drew. Maybe, well, no, because it's not gonna be curved. It's gonna be sideways, and we don't want that. Maybe we can use a straight line. Right. And there we go. That's slightly better. Still not great. All right. This has been your homework help for lesson 38. Hope you found this useful. If you did, hit the like button, hit subscribe for more videos on how to work through these Saxon problems. I know that we're all very excited about that. Extra credit. What can we use for extra credit today? Oh, there we go. Boom. There it is. You know what? Let's go with let's keep with the basketball team from yesterday. The Suns yesterday, the Phoenix Suns traded for a player from another team. So the extra credit is, who did the Suns trade for yesterday? And yesterday being, for those of you who decided to watch this on some future date, November 16th, 2020. Who did the Suns trade for on that day, or functionally agreed to trade for? So there's your extra credit. There's your homework help for these 30 practice problems. Hope you have a great day, and we'll see you later.